Here we go, y'all. We're going right into the Unit 7A review. I don't know why there's an A. Maybe it's just really long. Separate amount. I'm not sure. Okay. P of T is the size of the population. Which of the following differential equations describes linear growth in the size of the population? Linear growth. If a population has linear growth, right? This is an example of linear. The derivative of that, sorry, and I should use a t instead of an x when I'm doing dt, is, okay, what's the derivative of mt, considering m is a constant? That would just be m, and then the derivative of 0 would just be a number. The only one that for that is, okay? Guys, slope fields are kind of weird, so we got to figure this out. Okay, so I've got all these different ones. We got the slope field here. All right, actually, this kind of thing, it doesn't give me dy dx. What this is telling me is just kind of look at the shape. You know, like pick a point, start there, and just follow that. Kind of like that, right? If I picked a point, oh, follow. Okay. Does that look like x squared? No, x squared. Does that look like one of those? Possibly. Okay. Does that look like cosine? No. So I gotta remember the difference between e to the x and ln of x, right? You guys ever remember that? Check it out. E to the x, we have 2 points we use e to the 0 and e to the 1. E to the 0 is 1, e to the 1 is. You can remember that. 0, 1, 1. You can probably remember e to the x. Ooh, that does not look like e to the x. Let's look at ln of x. For ln of x, the two things I know, I can't do ln of 0, you're not allowed, but ln of 1 and ln of e. The ln of 1 is 0, the ln of e is 1. That's the point 1, 0, and then the point e1. And now I'm remembering, and I'm like, oh yes, that is ln. So if I forgot, I could very quickly just kind of remember, like literally with those 2 points, you guys can graph this, okay? All right, cool. Now this is what I was looking for. When you see like, okay, dy dx equals x over y or something like that, I'm like kind of looking for trends on these slopes. Jeez, it's so hard when this is on so many different pages. I guess I could kind of look at that. Okay, let me see here. Let me see what statements I can make about this. If x is 0, all the slopes should be 0. Now, x is 0, so it's like a point 0, 1, 3. These are all these. Those should all be at zeros. Nope, not on A. Those are all moving around somewhere. Nope, not on B. Ooh, this is looking good. That's looking good. Okay, so far I like C. Well, I like D. Okay, and I like E. Dang it. All right, so I eliminated A and B. That's fine. Okay, what is something else that I can say? How about if y is 0, the slopes are undefined, which means now you don't write undefined like that, you just don't write it. So what that means is that all along here, there shouldn't be any slopes. Okay, C doesn't have any. D doesn't have any. Oh, well, that helped me not at all. All right. Okay, so let's think about more stuff. In quadrant 1, when x is positive and y is positive, these should all have positive slopes. In quadrant 3, where x is a negative and y is negative, these should also all have positive slopes. Okay? And then over here, where it goes negative, positive, these should have negative slopes, and then positive, negative, these should have negative slopes. I'm just thinking about numbers I could plug in for x and y, so that's like one thing. So negative slopes, positive, positive, negative. Okay. Negative slopes, let's look good, positive, positive, negative. All right, C looks all right to me. No, this is supposed to have negative slopes here and positive slopes here, and it does. Good, eliminate one. Okay, negative slopes, yes. Positive, yes. Positive, yes. Negative, yes. Okay, so I've narrowed it down. C or E. Now, at this point, what are the big differences between C and E? Okay, the biggest difference is happening along here. Jeez, man, this is really, there's got to be an easier way to do this, but slope fields are not my best thing. I'm just not that great at. Let's look at the point 1 comma 5. What's happening? That is very, okay, so the slope would be very steep, whereas the point, I don't know, 1 comma 1 is not as. Now let's remember this was dy dx was x over y. Okay. 1 5 was steep. 1 1 was not as. Nope, that does not make sense. 1 5 is not steeper than 1 1. So it's gotta be right. This is not very steep like 1/5. That's more steep like 1. Yep, so it's gotta be okay. I like it. Okay, cool. Look at number 4. Oh, this is interesting. This is anyway, okay, just like kind of interpret the rate of change of volume of water in a tank with respect to time is directly proportional. This is stuff, you guys, that we used to teach in Algebra 1. I don't even know if you teach it anymore, if we teach it anymore. I know that, and I haven't taught it in a while. Directly proportional is an equation that looks like that. It means like as x gets bigger, y gets bigger. That's directly. Inversely proportional is an equation like that. That's inversely proportional. Okay. So, I mean, hopefully you kind of do that. So, dv dt is directly proportional, I'll just use k, to the square root of the volume, which is a differential equation that just the square root of volume. Okay, so first of all, hopefully you would go, definitely neither one of those. Square root of volume, not square root of time. And then the difference between these two guys right here, this is inversely proportional. This is directly proportional. Yes, you just kind of have to know. There you go. That's direct. All right. Okay, let's go and look at number. A curve has a slope, so let's say y prime at each point on the curve. Which of the following is an equation if it passes through the point 1? Well, how do I go from a slope to an equation? I integrate, right? So that's going to be x squared over 2, the 2's will cancel out, plus 3x plus a constant. Now, I can find I can basically already narrow it down to those, but I can find the constant by plugging in when x is 1, y is 2. So 2 is 4 plus c, so c is negative 2, so negative 2 is my constant. That's 10. Okay, cool. Sketching slope fields, you guys. Ooh, if this comes up on your AP test, I'll be so happy. It comes up every few. But yeah, here we go. Consider the differential. I'm gonna just write it down here so I can see it. Negative x y squared 2. Let f of x be a particular solution with the initial condition. F of negative 1 is 2. Sketch a slope field at the 12th point in. Cool. And then it's not asking me to solve it, so I don't actually really need that unless I'm solving. Let's just sketch this. You guys, literally, you're just plugging in every single point. The big thing here is to see if you can find maybe a pattern of something that would help you out. Patterns are okay. As an example, okay, let me start with this. Okay, so these are the points, negative 1, 0, 0, 0, 1, 0, okay? For each of those points, look, no matter what x is, if y is 0, you guys, anything times 0 over 2 is, right? They're going to be looking for you to draw 0 at each of those, okay? Shoot, let's take a look at these points. Well, I already did 0, 0. Next point is 0, 1, and well, if x is 0, these are also both going to be 0. Okay, patterns will really help you here. All right, the last 6 points, I mean, I think I'm just going to have to do them, but that's okay. All right, so I got the point 1, 1, 1, 2. 1, 1. Nope, 2, 1. I mean, I do have the, well, 1, 2 is up there, so that's fine. And then I got the point 1, and I got the 2, 2. And over here I got negative 1, 1, negative 1, 2. All right, let's go. Calculations. Okay, so this will be negative 1 times 1 squared over 2. So that's negative. The way I'll draw it there is I'll just draw one that is, they're going to be looking for it to be down and not like exactly down like that, right? So negative a half is more flatter, like not as steep, okay? Okay, 1, 2. That'll give me negative 1 times 4 over 2. That gives me negative 2. So the point 1, 2, that's a steeper negative slope. So I'd want to draw 2, 1. That would go negative 2 times 1 over 2. That's a negative 1. That's kind of like exactly at 45. That's like a negative. Okay. 2, 2. That's negative 2 times 2 squared over 2, which is negative 4. That's a very steep draw like that. Still negative. Ooh, looks cool so far. Okay, and then my last 2 points. Negative, negative x. That would give me 1 times 1 squared over 2. That gives me a half. This is a positive, but a kind of slope. And then negative, negative 1 times 4. That's a slope. Okay? And they'll literally just check to make sure they're direction. Right? The reason that they give us this is so that we can separate the variables, but it's like not asking me to do that, so okay. Whoops, this one. Take a look and see if that's more or less how they drew it. Oh yeah, that looks really good. Okay, perfect. And let's see how the grading is. The non-zero slopes, if you got like the slanty ones right, you get a point, and all the zero slopes you get. Okay. Consider this differential equation. Sketch a slope field at the 9 points indicated. Let's practice sketching this slope field, okay? Do I have any patterns? I mean, not that I can see right off because I'm not multiplying anything. So I'm going to just go ahead and go x, y, y, x. And I'm just going to crank it. Okay, let me list these points. That's the point. Negative 1, 0, 0, 1, negative 1, 1, 0, 1, 1. Then, I'm just keep going through here. Negative 1, 2. All right. Yeah, I'm halving all the x's plus y minus 1. That's good. Half of that plus 0 minus 1, that's negative 3s. 0 plus 0 minus 1, let's say 1. And half plus y minus 1 is negative half. Okay, so the way that these will look is kind of a, that's like 1.5. A slightly bigger than 4 steepness, and then, oh, going this way, sorry, a 45 steepness, and then a slightly left. Okay? Do the next one. Okay, this is going to give me, right over here, negative 1/2. That'll give me 0, plus 1 minus 1, that'll give me 0, and 1/2. Okay. Okay, so, oh gosh, negative 1, that gives me kind of a flat slope. That gives me a slope of 0. That gives me a positive kind of, oh, weird. I don't know about this. And then, okay, negative 1/2 plus 2 minus 1, that's a half. 0 plus 2 minus 1, that's 1. 1/2 plus 2 minus 1, 1.5, that's 3/2. So these are all positive slope. This goes at positive half, positive 1, positive 3/2. Oh, gosh, sorry about that. Okay. I mean, let's see what it looks like. No, that was the last one, sorry. There we go. Boom, 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 boom. Yep, that's what I got. Okay. Weird, weird. 2 points are earned for each sign in the relative steepness in rows. All right. That one was a weird one, but okay. Ooh, yay, last question. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. What difference? Oh, I guess it. Okay. Find the values for m and b if y equals mx plus b is a solution this difference. Okay, well, I don't really know what I'm doing, so let's just kind of try something, I guess. Dy dx, the derivative would be m, then everything else goes away. Okay, so let's see if we can plug some stuff in. I truly, you guys, have no idea what I'm doing on here, but I know I just found dy dx. I know what y is, so I mean, I'm gonna plug it in and see what happens. So dy dx is m, y is mx plus b minus 1. Okay, 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 let's see, let's see. So let's say I take out, so 1/2 plus m is the x value, b minus 1. And okay, geez, let's think about this, you guys. This is an x value, but there's no x value on the other side. There's just an m value, so it's 0x plus m. So what I'm going to do is I'm going to set the x value parts next to each other, which means 1/2 plus m equals 0. And then I'm going to set the non-x value parts next to each other. B minus 1 equals m. Weird, but let's go. M is negative 1/2. B minus 1 is negative 1/2. I add the 1 over. B is positive 1/2. I'll be shocked if this is right, but let's see. So M and B would be, M would be negative 1/2. B would be positive 1/2. I mean, I don't know. Maybe. I don't really know what I did there, but everything looks all right to me, yeah? Oh, let's freaking go. Do you guys see that? Let's go. That's so amazing. Wow. Shocked that I got that. I mean, not really, not totally not. But I want you guys to see this sometimes. Man, you just go for it. And you're just like, I'm gonna just start plugging stuff in. See what happens. Okay? Hey, that was fun. I'll see you on the flip side.